Hi everyone and welcome to the Learning Curve. In this video I'll be looking at linear relationships. In particular, I will be looking at how to generate linear equations from word problems and how to manipulate those equations to generate predictions for either the dependent or independent variables based on given values. This topic is very common throughout most of mathematics and is the foundation of several mathematics topics which are studied in the middle and high schools. Here we are told that a company makes custom shoes which it sells to customers for $10 per pair with a one-time branding cost of $25. We are asked to write a linear equation to represent the relationship between the cost of shoes for customers, Y, and the number of pairs of shoes bought, X. First thing we want to establish here is that Y represents the dependent variable, that is, the cost of shoes bought by customers will be dependent on the number of pairs of shoes bought, which is the independent variable, X. The dependent variable relies on or is influenced by the independent variable in terms of the determination of its value. So our equation here is going to be a linear equation, and the standard form of a linear equation is y equals mx plus b, where mx is our variable component, m is particularly our slope, and b is our y-intercept or constant. So based on the scenario given, we are told that it costs $10 per pair of shoes. That $10 per pair of shoes will be our coefficient of x, which is our slope. So the $10 represents our slope. And the one-time branding cost of $25 represents the constant value or our constant y-intercept, which is b. So that's plus 25. So 10x would be our variable cost, reflecting the fact that the more shoes, more pairs of shoes the customer buys, the more it will cost the customer. So that is why it was logical to use 10 as the coefficient of x, which is the slope, which is the changes that will be generated the more pairs of shoes that are bought. So this is our equation. 10x plus 25. 25 is just a one-time cost. So regardless of how many pairs of shoes the customer buys, that 25 will just be a one-time cost for this pair of shoes. It will only be paid once. So that's why it is the constant value. So that is the equation that describes this situation. Now we are asked in B to use the equation derived to find the cost of 4 pairs of shoes. So again, writing back the equation here, y equals 10x plus 25. We recall that x is our independent variable, which is the number of pairs of shoes bought. Since the equation asks what is the total cost of 4 pairs of shoes bought, then essentially we're asked to find the value of y if x is equal to 4 or when x is equal to 4. So pretty much what we'll do here is to just replace x, number of pairs of shoes bought, with 4. So it will be 10 multiplied by 4 plus 25. Okay? Now 10 multiplied by 4 here is going to give us 40. So 40 plus 25 is going to give us 65. So what this 65 represents is the total cost that the customer will incur when he or she buys 4 pairs of shoes. Remember that 10x means 10 multiplied by x. So when we substitute 4 for x, we'll simply multiply that by 10 as well. Question C is similar. it says, using the equation derived, what is the total cost for 15 pairs of shoes? So again, we go y equals 10x plus 25. So again, what we'll do here is to substitute the number of pairs of shoes, which is 15, for x. So this will become 10 multiplied by 15 plus 25. So this will be 150. 10 multiplied by 15 will be 150 plus 25, which is going to be equal to $175. So what this is saying is that it will cost $175 y to purchase 15 pairs of shoes x. As indicated earlier, y is the dependent variable, yes, and x is the independent variable. The independent variable is the variable that stands alone, which exerts an effect on the dependent variable y, and y is influenced by or depends on the independent variable x for its value as illustrated. D and E are a little different. Here we are told if a customer spends $100, approximately how many pairs of shoes will he be able to buy? So let's write back the equation here again. The equation that describes our scenario is y equals 10x plus 25. In this case, we are not given the value of x to find y. We are instead given the value of y, which is the total cost, to find x. That corresponds with that total cost. So 100 would be equal to 10x plus 25. And what we need to do here is to simply transpose for x. I'm going to continue the problem over here. So to transpose for x here, let us look at what is being done to x. What is being done to x is that it is being multiplied by 10, and 25 is also added to it. So since x is multiplied by 10, and 25 is added to it, then we have to do the inverse of both of those operations to try and get x on its own, because x is what we're trying to solve for. So we're trying to isolate x. In order to isolate x, we have to do the inverse of what is being done to x. Since x is multiplied by 10 and 25 is added to it, then we need to do the inverse of both of those operations to x, which would eliminate those values that are a being multiplied by x and b being added to x. What you do to one side of an equation, you have to do to the other side as well. So in effect, x will be left on its own on the right hand side of the equation when I carry out the necessary inverse operations. And the inverse of dividing by 10, sorry, the inverse of multiplying by 10 is to divide by 10. And the inverse operation for adding 25 would be to subtract 25. That is what we do to both sides of the equation. We would get x on its own on the right side when we do that to the right side. And on the left side of the equation here, the 100, which is already there, we would subtract 25 from it because 25 was added to x, so we're doing the inverse operation. And would divide by 10 since x was multiplied by 10. So that is the inverse operation. So in effect then we would be left with x equal 75 divided by 10, and 75 divided by 10 is 7.5, which is our answer. But number of pairs of shoes is a discrete measurement, which means that it can only be a whole number. So we would logically approximate this to the nearest whole number, which is 8. So roughly 8 pairs of shoes would cost the customer $100. Question E is similar. If the customer spends $250, so let's rewrite our equation here again that we derived earlier, y equal 10x plus 25. Okay, y equal 10x plus 25. Now what we're going to do here is that we're going to substitute 250 for y, because what we're trying to do here is to find the value of x. So 250 would be equal to 10x plus 25. Yes, 10x plus 25. And again, what is being done to x here? We're multiplying by 10 and adding 25. So we're going to do the inverse operation to both sides of the equation. So x will be on its own on the right side. We would isolate x. The operation would successfully isolate x on the right hand side. And on the left hand side, we would have 250, take away 25, and we're going to divide all of that by 10. So 250 take away 25 would be 225, and 225 divided by 10 would be 22.5. But we'd approximate that to 23, again, because we can't have 22 and a half pairs of shoes. That would be a discrete measurement. So it would be best to approximate this number to the nearest whole number, which would be 22.5. So roughly 22.5, or rather roughly 23, approximating it, roughly 23 pairs of shoes would cost the customer $250. That would be the interpretation. And for the final question here, is the relationship between the number of pairs of shoes ordered, which is X, and the total amount spent, which is Y, is that proportional or non-proportional? Keep in mind that X and Y are just symbols here. We could have used any pair of symbols to model the situation. We could have used C for cost and maybe X or Q for the quantity of shoes bought. So just understand that they are symbols. The key thing to understand is the nature of the relationship in place. So the equation that we have is y equals 10x plus 25. The question is, does this represent a proportional relationship? And the answer is no, it does not. It's non-proportional. A proportional relationship would take the form y equals just mx or kx, where the y-intercept is 0. But the y-intercept is not 0 in this case. The y-intercept is a non-zero value, which is 25. So because of the fact that the y-intercept is a non-zero value, the equation that we're working with does not take the form y equal mx, so it's not proportional. That would be the reasoning. The reasoning as to why this is not proportional is because y equal mx is the standard form for proportionality, where the y-intercept would be 0. But in the function that we're working with, y equals 10x plus 25, the y-intercept is a non-zero value of 25. So proportionality is not satisfied by this. Okay? So that would be why this is not proportional. The proportional form, again, is y equal kx or y equal mx. Any function that takes that form shows a proportional relationship. But once you add or subtract a constant apart from 0 from that mx, then it becomes non-proportional. So the answer is no, and that is because this function has a non-zero y-intercept, which is exactly 25. All right, proportional form would be this: y equals mx, where the y-intercept would be 0, because y equals mx could be expressed as y equal mx plus 0. It's the same as y equal mx. So that would be the reasoning behind that. Thank you for your time. I hope you found this simple lesson to be very instructive and easy to follow. I look forward to seeing you again. Continue to tune in to the learning curve as we continue our discourse and indulgence in the world of mathematics.